So as we demonstrated in our previous video, which is the workings of a selection sort, if you don't know what it is, I'm going to provide a link in the description below, as well as to my blog post about selection sort. So please check it out, because this video will make more sense if you watch that video. All right. In the selection sort workings, we had shown three important variables. One of them is our FUI, which stands for first unsorted index. And what is this? This is the position data set where the first sorted element lies, right? And the next most important variable we discussed in the earlier video is SP. In that video we called it S_P, but over here we're just going to call SP for simplicity's sake. It's easier to write and quicker to write, which is basically the position of next smallest element found. Right? I don't think there's any more explanation to it. And we're going to write CI, which is basically previously we called it. We're going to write here if someone is verifying it previously S_P. So CI, which is the position of the element that comparing against the small. So that's the position of the element that we're comparing against the smallest element. Found. Alright, so that would be the smallest element found so far would be pointed by the position SP. Okay. Alright, so that summarizes our key variables, which is FUI, which is the first unsorted index, SP, which is the position of the next smallest element found, CI, which is the position of the element that we are comparing against the smallest element found so far. Okay. Alright, so as we know, let's start. Things are better explained when we had a small data set. Okay, so we're gonna write our data set right here, 0, 1, 2, 3, and let's use the same elements as in the previous one, which are, if I remember, there are 8, 12, 6, and 5. All right, so if you guys remember the previous video, what we did was initially our FUI is equal to pointing to position 0, and we compared 8 with position 8 with whatever the value. Let's do this. Let's do 12, and then we compared position 8 with position 6, and we updated our SP to position 2 at that point, and then we did compare 6 with 5, and which is comparison here, and our comparisons are green, guys. So updated sp is equal to position 3, and then we did a swapped 5 with 8 and so on. So if you guys start to pay attention, there's a thing here. There's a thing where if for a value of 8, for a FU of 8, our CI moves from position 12 to 5, and which basically means for position 0 our CI moves from position 1 till position 3, and for FUI, which is the first unsorted index of 1, our CI moves from position 2 to position 3 and so on. With that said, it's pretty obvious, and as we know the position of FU, so we can summarize that our first unsorted index would move from position 0 to position 2. And why is that? Because with each iteration we would find ourselves sorting our data set with each pass. Actually, pass 1 FUI is equal to 0, and when we come down to pass 2, we find ourselves like this: 5, 12, 6 and 8, and with FUI of 2, which should be our pass 3, we'll find ourselves with 5, 6 and 8, and with FUI of 3. So we do pass 4, should get us 5, 6 and 8 and 12. So sorry, let me write down. FUI goes from 0 to 3, and for each value of FUI 0, our CI goes from value, let's write down the positions here so that it's easier. Okay, so let me back this 0, 1, 2, 3. Nice line. Okay, so that's there, and we would see for CI would be go from 1 to 3, and CI would go from 2 to 3, and CI would go from, I guess, this point 3 to 3, and in this case FUI is a 3, and there's nothing else need to be done. Okay, so so as we see a trend here, we need to set FUI. So let me use a brown color for a program, and I'm going to give some gap. So we're going to write down here solution. So for, let's say our data exists in an array called data, and for int FUI is equal to 0, FUI less than or equal to let's do this. It's easier to read. N is equal to data dot size n minus 2. Remember, when there are 5 elements, our FUI can only go as far as 3. FUI plus plus, and the reason for that is explained in my blog. And for each value of FUI, we do know that CI goes int CI goes from FUI plus 1 all the way till CI is less than or equal to n minus 1 and CI plus plus. So that's our basic structure. That said, what would happen inside these for loops is the question now. So we do know that, if you remember, if you watch my other video for workings, we do know that the data at position CI, which is the current index or a comparing index, would be compared and checked if it is lesser than the data at position SP, which is the position of the next smallest element. So we're going to write that down. If data at position CI is less than data at position SP, then what we need to do is we need to update SP, which is the smallest position found so far, to point to wherever CI is pointing to. Alright, so with that said, when we reach the end, when we compare our assumed smallest element with every other element in the array, and we reach the end of the unsorted set, we know what is the smallest element, and we need to swap it with our initial assumed position of the smallest element. To do that, what we do is, since our initial assumption of the smallest position is stored in FUI, and we do know that we need to initiate our SP to point to wherever FUI is, because that is our initial assumed smallest position, until we actually found one real smaller position using the logic here. So let me initialize in SP outside. Let's call it int SP is equal to 0 or whatever, and we are going to see if FUI is any different than whatever SP is pointing to, and if it is, then we do a swap. To do a swap, you need a temporary variable. So if you care, we can declare a temporary variable here, or we can declare one outside, but whatever. Int temp is equal to data SP, and the data that is being pointed by SP is replaced with the data that is being pointed by FUI, and now the data at position FUI, which is our first unsorted index, would be pointing now to the data at position SP, which is the actual location of the smallest element in the array. So with that said, we close our braces for our outer for loop, which is the for loop for our FUI, and that's it. So what we did was we set SP to 0. We initialize our n to point to the size of the data set, and we iterate over FUI from 0 to n minus 2, which is basically the one element before the last element. And the reason we do that is by the time the sorted set came over to the element just before or just to the left of the last element, it already has all the elements sorted. And the last element is obviously the largest element in the set because the sorted set already has all the smaller elements. So there's no point in doing anything with the last element. So with that said, then that is the reason why FUI is pointing to n minus 2, and then we update the FUI and we initially make an assumption that the position of the smallest element is the first unsorted index, or the position of the first unsorted element, and then we compare that element with every other element every other unsorted element in the data set. So to do that, we're going to initialize a variable called CI to the element right of the first unsorted element by doing CI is equal to FUI plus 1, and we will continue our CI until the end of the data set, which is pointed by n minus 1, and we do an if where we compare the data at the position that is being pointed by our current index, our comparing index, with the data at the position that is being pointed by our smallest position pointer. And if we found that data at the position that is being pointed at current index is smaller, we'll update our smallest position to point to that location of where the current index or comparing index is pointing. And we do that, keep doing that until CI reaches the end of the array, and at that point, we got nothing else. Our SP would have the smallest element, and we'd exit that loop, and then we'll see if our initial assumption of the smallest element, which is still in FUI, which is, if it is different than what we found, which is stored in SP, and if it is, then we do a swap of those elements, and at that point we exit our external loop and we proceed with the next unsorted element. So there is a program, guys, and here is all the notes, and here is the solution. I wish I could fit it in one window, but nope. All right, thank you guys.